Hello friend, welcome to my YouTube channel Electrical Boost. Today we are going to discuss coupled circuit. Okay, it is a important chapter in electrical engineering. Okay, because we all of our electrical machine field or any field we use coupled circuit. Okay, first of all we want to know what is the coupled circuit. What is the coupled circuit? We already discussed what is the circuit in the network theory. Okay, basic network theory basic. But coupled theory, what is the coupled theory? Okay, where the coupled circuit is exist. Okay, where the coupled circuit is exist. Basically, an electrical circuit, coupled circuit also is an electrical circuit, but we say that an electrical circuit is said to be coupled circuit when mutual inductance exists between two coil or two coil. Here you consider only coil because there is more mutual inductance in the coil, or you can say the coupled circuit is likewise when energy transfer take place between two circuit by the help of magnetic field. If whatever the amount magnetic field is present, then you can say the coupled circuit. Okay, before going to the coupled circuit, we small topic introduce, that is the dot convention. After that we discuss how many type of coupled circuits exist. Okay, this is the dot. Okay, it is used to find out the voltage polarity of induced EMF in the coil or coupled circuit, or in the coil due to mutual inductance. Okay, we make identification. Okay, so that we make dot convention. He say if the current entering to the dotted terminal okay, dotted terminal, due to this current a mutual inductance develop voltage in another coil, other coil, the dotted terminal is positive polarity. Next, if the current leave from the dotted, then dotted terminal is negative polarity for voltage. This is only for mutual induction, we discuss that topic. Okay, just remind this and we go to the next. We clarify your dot convention. Okay, next we go to the types of mutual inductance. Here write types of mutual inductance. Types of coupled circuit. Okay, one is there are so many type of coupled circuit, but we discuss only electrical coupled circuit, and one is the magnetically coupled circuit. Before that, you have some doubt about this. You think the coupled circuit is no physical connection between them, but there is a physical connection and there is no physical connection. This is so that this is two type. Okay, first we discuss the type 1. This is electrical coupled circuit. Electrical coupled circuit. What is electrical coupled circuit? Okay, when the physical connection between the circuit or coil, physical connection exists. Okay, then this called electrical coupled. Okay, let's see here one inductor like this. Okay, and another inductor connected in series. They are physically connected by the help of wire. Okay, they are physically conductors. Let this is coil L1, inductance L1, and this is L2. And we provide some voltage. Let this is V. Okay, let this is V, and this is the positive terminal and the polarity, and this is the negative. Okay, and between those two we mark the dotted terminal like this. This is the dotted. Okay, for this in the coil 1 dotted, and this is for dotted. Okay, here the current entering like this. Let this is I. The current will same here also. In the both coil, current is entering the dotted terminal. So the polarity and a mutual inductance exists between them. This is, say this is M. You can see this. Okay, and the polarity is, and the polarity, voltage polarity plus minus, and this is the plus minus. Okay, here in this coil there is two EMF. One is for self inductance, another is for the mutual inductor, This mutual inductance for this coil, and here the mutual inductance for this coil. Okay, for finding the total equivalent resistance, we go like this. Okay, here you can apply KVL. Apply KVL in the circuit, Kirchhoff's voltage law. Okay, you can just write like this, and this V, you start V voltage, supply voltage V minus EMF induced due to the self inductance L1 di by dt, you already know. Then what amount of EMF induced due to the mutual inductance. Okay, here the decide the polarity, because here the current entering the positive polarity, so here we also same polarity. Okay, so this is also negative. Okay, this is M di by dt. Okay, then you go to this coil, this is also L1 di by dt, and this is M, same current, di by dt. Okay, let me separate these two. Okay, how this separate? V equal to, we can write L1 di by dt plus, sorry, this is L2 di by dt. Here both mutual induction added, 2M di by dt, Okay, so we can just write V equal to L1 plus L2 plus 2M, take di by dt common, di by dt. Here the voltage, the total voltage, we can just write L equivalent di by dt, this voltage, you can write or not. Okay, we already know like this, we know V equal to V in inductor. Okay, L di by dt, here the total voltage. Okay, so we can write like this, yes or no? So L1 L2 plus 2M di by dt. Okay, we can cancel out di by dt, then you find finally what you get. Finally you get L equivalent equal to L1 plus L2 plus 2M. Here the two mutual added, so this type of connection or this type of dotted is known as series adding. This is the adding. Okay, and one, if we like this, if you connect like this, you can here I write. Okay, if you connect just dotted terminal here and there. Okay, this is the voltage V. Okay, this is L1 L2 and between this mutual inductance. Okay, here you can write KVL equation like this. Okay, you can see that here I write V minus inductor current is like this. Okay, here the current entering to the L1 is dotted terminal and current leave from the dotted terminal in L2. Okay, so here the L1 di by dt, but mutual inductance is polarity different because the current leaving from L2. Okay, we said that previously the mutual induction due to the another current, another coil. Okay, so this is plus M di by dt. Okay, and this is minus L2 di by dt and plus M di by dt. By solving this, we get L equivalent equal to L1 plus L2 plus minus 2M. This is the subtract, this is the series opposing, this is the series of, here you can say this is minus 2M and this is plus 2M. Okay, this is adding and this is the opposing type. This is the adding and this is the opposing. In our next video we discuss what is the problem related to this type of dot convention, so you can clarify your doubt. Okay, next we going to discuss what is the magnetically coupled circuit. What is the magnetically coupled circuit? Okay, magnetically coupled circuit. Magnetically coupled circuit. Magnetically coupled circuit. Okay. When the two coil or circuit, there is no physical connection. There is no physical connection between them. There is no physical connection between them. Here two coil. Let this is L1 and this is L2. There is no connection between by the wire. Okay, there is no physical connection. We can say no physical connection. No physical connection. No physical connection. No physical connection. Okay, let the supply voltage from this coil to this coil be V1 and this is V2 across this coil. Okay, let current I2, this is I1. Okay, and mutual inductance between those two, this is N. Okay, here dotted terminal is like this. Okay, here you can say first we write the equation for say primary coil and write the equation for the secondary coil. This type of magnetically coupled circuit used in electrical machine circuit, okay, or transformer circuit. Okay, here for primary you can write for primary how much this coil. Okay, you can write this is V1 when you apply KVL, V1 minus L1 di1 by dt, then minus the mutual induction due to this current, due to the second coil current. Okay, so we can write M di2 by dt. Here in this case what thing, this is the series, so that what happened, so same current will flowing. Okay, but here the coil are different, so the current is also different. Okay, if you write this is the equation, we can write V1 equal to L1 di1 by dt plus M di2 by dt. Okay, this is the adding. Okay, this is the adding. When you check the secondary, for secondary what happened, see, this is V2 minus L2 di2 by dt. Here the mutual induction due to the current I1 from due to this coil na? Okay, M di1 by dt. Okay, this is V2 equal to L2 di2 by dt plus M di1 by dt. Okay, this is the magnetically coupled circuit. Okay, another method, if the dotted terminal is opposite, okay, you can say like I write this equation also. Let I2, this is I1, this is V1. Okay, this is V2. Okay, let dotted terminal here and dotted terminal here. Okay, so if you write for primary, okay, this is V1, okay, minus L1 di1 by dt. Here the positive, because current is leave from. Okay, so this is M, here the negative and here the positive. Okay, di2 by dt. Okay, you can write V1 equal to L1 di by dt minus M di by di2 by dt. Okay, this is the subtract, this is the opposing, this is the opposing the total inductance. Okay, next for secondary, okay, what happened? This is V2 minus L2 di2 by dt plus M di1, opposing na, I1 by dt. Okay, this is V2 equal to L2 di2 divided by minus M di1 by dt, di1 by dt. This is for adding, this plus is added, okay, and this is also added, okay, and this is subtracted, minus, okay, this is also minus, okay. This is the adding and this is the opposing, this is the opposing. The brief discussion in our problem case, okay, in our problem on coupled circuit or question, when you do the question about coupled circuit, okay, this is all about the basic about the coupled circuit. We later discuss depth on the coupled circuit. If any doubt, please comment. Okay, thank you for watching this video. Please like and share. Thank you.